Good afternoon. We're going to be doing evaluating expressions and formulas. This is a part of Unit 2 for Math with Business Applications. You can be found in your supplement, Part 6. An expression is a collection of variable terms and constant terms. It will not contain an equal sign, and the value of the expression is determined when the value of the variable is known. It's important to note that expressions are evaluated using substitution. For example, if we know x is equal to -2, evaluate the expression 5x squared plus 2x. So what we're going to do is we're going to substitute -2 in for x, being sure to use parentheses. This gives us 5 times the quantity -2 squared plus 2 times the -2. Which when using the order of operations gives us 5 times 4 plus 2 times a -2. 5 times 4 is 20. So we have 20 plus 2 times a -2. And 2 times a -2 is -4, giving us 20 plus a -4, which is the same as 20 minus 4, or 16. Therefore, if x is equal to -2, then the value of the expression 5x squared plus 2x is 16. When we evaluate an expression, we're basically using 3 steps. The first is we're writing out the problem. The second is substituting in the value of the variable, being sure to use parentheses. And the third is a simplification of the problem using the order of operations. In our second example, we have a -2x times the quantity x squared minus 3x plus 4, for x is equal to 5. We're going to substitute 5 in for x, being sure to use parentheses. This gives us -2 times the quantity 5. Opening parentheses, we would have the quantity 5 squared minus 3 times the quantity of 5 plus 4. In many cases, that double parentheses there would be replaced by what's known as a square bracket. So we would have -2 times the quantity 5, and then we would have a square bracket, and inside of that, we would have the quantity 5 squared minus 3 times the quantity 5 plus 4, and the square brackets. The square brackets here have no other purpose than to replace the double parentheses. They serve only as a visual cue. They make no difference in the problem other than that. So, using the order of operations, we would go inside the larger parentheses, which are now square brackets, first. Squaring the 5, we have 25. So, we would have a -2 times the quantity 5. Opening a square bracket, we would have 25 minus 3 times the quantity 5. Plus 4, closing the square bracket. Again, inside the square brackets, we would do the 3 times 5, which is a -15, or is a 15, sorry. We would have a -2 times the quantity 5. Opening a square bracket, we would have 25 minus 15 plus 4. Since we only have addition and subtraction inside the square bracket, we would do that from left to right, getting a 14. So we would have 2 times -2 times the quantity 5 times the quantity 14. -2 times the 5 is a -10. So -10 times 14 is a -140. On this slide, I have 2 sample problems to try. Looking at the first problem, we have that the answer to this is -8. Looking at the second problem, I ask that you take a minute, pause the recording, and see if you can calculate the answer. Resume when ready. For the second problem, we have that the value of the expression would be a -1/60. The second part of this lesson is about formulas. Formulas are equations. They are solved using substitution. Multiple values are often known, but usually one is missing, and that's the one that we are solving for. On the right-hand side, you will see that there is a link to a YouTube tutorial. You can either click on the link here to get it started, or you can copy and paste this link here into your browser. To solve formulas, we use essentially the same 3 steps. We will copy the formula. We will substitute in the value of the variable, being sure to use parentheses. And then we will simplify that expression using the order of operations and solve, if necessary, using the inverse operators. In our first example, we have z is equal to the quantity x minus b over n. When n is equal to 35, b is equal to 16, and x is equal to 9, find z. So writing out the formula first, we will then put in our substitutions, being sure to use parentheses. Using the order of operations, I will do 9 minus 16 first. This is a negative 7 divided by 35. This is the same as a negative 7 over 35, which reduces to be a negative 1/5. Thus, the answer here is that z is equal to a negative 1/5. Please note that we would not put in the decimal form unless asked to. In the second example, if S is equal to an M over LC, when S is equal to 120, M is equal to 800, and C is equal to 10, then find L. So again, starting with the formula, we then make the substitutions, being sure to use parentheses, and we have 120 is equal to 800 over 10L. Simplifying what we can, 800 divided by 10 is 80. This gives us 120 is 80 over L. Notice that L is not isolated. It is not alone on one side. So we will first multiply both sides by L to get it out of the denominator. And then we will divide both sides by 120 to get L is equal to 80 over 120, which reduces to 2/3. So our value of L here is 2/3. On the next one, what we have is again a concept check. Please look at the first sample problem here. Pause your video and resume when you're ready to check your answer. The answer to the first example is that z is equal to 3.65. If you're ready to complete the second example, please note that you're solving for the little b. There is a difference between the capital B and the lowercase b. You are looking for the lowercase b. Please take a moment to solve this while pausing the video. When you're ready, resume the video again. The answer to the second problem is b is equal to 2.165. These examples bring us to the end of this particular lesson. You will find that there is extra practice in your supplement on pages 12 through 14, and there is a graded assignment covering this material on WebAssign. Please don't hesitate to contact me if you have any questions.